And moving on to question 3. A random variable x has probability density function given as shown on the screen. K is a constant. Show that k equals 1/4. Show that questions always give us an opportunity to be sure we've achieved our marks. So a fact that will be useful here is that for all continuous random variables to be valid, if you integrate in between the smallest value of x and the largest value of x, the result should be 1. What we'll look to do here is to integrate the two separate functions, add them together, and the result should be 1. So I'm integrating kx squared with respect to x in the between 2 and 0. If I add that on to the integral of k 1 minus x over 6 in between 6 and 2, I'm expecting the answer to be 1. So we'll go ahead and process this integration. It's useful to take the constant out just to make the calculation simpler for ourselves. Integrating x squared is 1/3 x cubed in between 2 and 0. Once again, I have an opportunity to take a constant out. I'll take that opportunity. And integrating gives us x. And here, I'm going to have x squared over 12, which I'll write like this. This is in between the limits of 6 and 2, and the result should be 1. So in processing this, I should now only need to substitute in these values. So substituting 2, I should have 1/3 times 8. And substituting 0 is just going to give me 0. And on this side, substituting in a 6 will give me 6 minus 36 over 12. We'll simplify in a minute. Minus 2 minus 4 over 12. Which still should sum to 1. Okay, let's do some simplifying. I know that this is going to result in 8 over 3k plus, on the calculator or with some mental maths, we should get 4 over 3k equal to 1. Summing these together, 12 over 3k equals 1. 4k equals 1. Very happy with this result because that leads to what I needed to prove, which is that k equals 1/4. Okay, starting with the fact that integrating the entirety of the continuous random variable should get me an answer of 1. I've managed to prove what the question asked me to. Write down the mode of x. Okay, going back to the actual continuous random variable here, what would a sketch of this continuous random variable look like? Firstly, I know I have some quadratic function occurring in between 0 and 2. And then I actually have a linear function in between 2 and 6, with that linear function being a negative linear. A general sketch of what this looks like. Let's put in some of the necessary values, 2, 4, and 6. Firstly, my quadratic. It's going to take me to some value up here. And then my linear is potentially going to come down like this. The main point here is that after x equals 2, I know that the graph or the PDF, is going to be a reducing value. So the maximum this PDF will ever be is when the value of x is 2. And through that understanding of the two separate functions that we have, I should be able to tell that the mode is going to occur when x equals 2. The highest part of the graph will occur when x equals 2. The largest value of f of x occurs when x equals 2. Okay, moving on to part C. Here we've been asked to specify fully the cumulative distribution function f of x. Actually, for me to be able to do this, I would like to write out the PDF with the value of k inserted. Okay, so a reminder, for us to find the cumulative distribution, we need to integrate each of these functions in between x and the lower limit that the function is valid for. So firstly, I'm going to go ahead and I'm going to integrate 1/4 of x. So I'm integrating in between x and 0, 1/4 of x squared. I'm going to put the constant on the outside and just work with the x squared. That should lead to 1/4, a third of x cubed, in between x and 0. I'm going to go ahead and substitute. It's always nice substituting the x value. It should match your integrated function anyway. And then I'm going to subtract 0. Easily enough, the integrated function for the first interval, 0 to 2, is going to be 1/12 x to the power of 3. Okay, now I'm going to want to integrate the second function in between x and the lower limit of 2. Once again, I'm going to take the constant outside, x and the value of 2, and I'm integrating 1 minus x over 6 dx. Okay, so I'm going to have 1/4 I'll rewrite this as 1/12. And this is in between x and 2. So again, substituting in the x should just give me the expression on the line above. Now I need to subtract 2, substitute it into that expression. So that's going to be 2 minus 4/12. And this will lead to 1/4 x minus a 12th of x squared and this will lead to x minus 1/12 of x squared minus 5/3. Still need to do a little bit of work to make sure that I have the correct cumulative function for the second interval. I need to actually add on f of 2. So this is the value of 2 substituted into the cumulative function of the previous row. So that's 2 substituted into 1/12 of x cubed. So we're not quite done. X minus a 12th of x squared minus 5/3 plus 8/12. Okay, just being careful about the fact that I want to bring that into an expression that already has 1/4 factorized out. I could potentially rewrite that in this form. And that lets me see a little bit easier what I'm going to get when I bring it into the bracket. I'm going to have 1/4 Okay, so I have the two main parts of the cumulative distribution worked out. All that's left is for me to write it all in the necessary form. So the cumulative function of x, since my PDF had 3 rows, the cumulative distribution function is going to have 4. The first one will always be 0. The second one we found to be 1/12 of x cubed. Third one, in all its glory, is 1/4 x minus 1/12 of x squared plus 1. And the last row will always be 1. So we wouldn't be awarded all of our marks yet unless we put in the correct intervals. For the first row, this is for all x values less than the lowest limit used in the question, in this case 0. Here we have all the x values in between 0 and 2, all the x values in between 2 and 6, and finally we describe the probability as 1 for all x values greater than 6. And this final statement is the complete cumulative distribution function and will be worth the marks in the exam. And on to the last part of the question. Part D, we're asked to find the upper quartile of x. Okay, so up to now, we have 2 different functions that we may have to use. We first need to determine whether the upper quartile will be contained within the first function, 1/12 of x cubed, in the interval 0 to 2, or will it be contained in the second function and be in the interval 2 to 6. To do this, we will evaluate f of 2. In substituting 2 into the corresponding expression, we get 1/12 of 2 cubed. 8/12, which cancels down to 2/3. As a decimal, this is 0.6 recurring, and actually I've not reached the point of the upper quartile, which would have a probability of 0.75 below it. So currently I know that the value 2 has a probability of 0.6 recurring below it. The upper quartile must be in the next interval. If there were more than 2 intervals, I would keep on evaluating the upper limit of each of the cumulative distribution functions until I realized or determined which interval contained the upper quartile. Okay, so here I know it's the second interval that contains the upper quartile. I would like to know the x value for which the upper quartile exists. So I'll go ahead and put the function equal to 0.75 and evaluate from there. Okay, first thing to do, I'm going to multiply across by 4. Now I actually want to eliminate any fractions from this. I find it a lot simpler to work without the fractions. So multiplying by 12. And then I'm going to rearrange it to a more user-friendly form of the quadratic. Okay, at this point it's probably going to be quadratic formula that's going to get us our answer. So that will go into our calculator. with the corresponding coefficients, A being 1, B is -12, and C is 24. All of these into the quadratic formula. So negative B plus or minus the square root of B squared minus 4 times A times C. All of that will be divided by 2 times A. Time to grab a calculator, plug this all in, and we should get two answers, one being 2.54 and the other being... Okay, so to choose which one of these is valid, we're just going to look at the limits of the continuous random variable, which is only defined in between 0 and 6. So this value cannot be the one that we're looking for, and we then conclude that the upper quartile is going to be 2.54. Q3 equals 2.54 will be our final answer.